Let us continue the lecture on introduction to linear differential equation with constant coefficients. I have already told you when the RHS fx is equal to 0, then the general solution is complementary function only. When the RHS fx is not equal to 0, general solution is equal to complementary function plus particular integral. Suppose when the RHS is 0, then general solution is complementary function, I told you. So it depends on how to write the complementary function. It depends on the nature of the roots. Suppose there are say 4 roots m1, m2, m3, m4. All the case 1, if all these roots m1, m2, m3, m4, they are not equal. If all the roots m1, m2, m3, m4, they are not equal. What is the complementary function? C1 into e to the power. First root m1, observe, C1 into e to the power. First root m1, m1x plus C2 into e to the power. Second root m2, m2x plus C3 into e to the power. Third root m3, m3x plus C4 into e to the power m4x. For example, you are given a differential equation. You are finding the roots either by operating the calculator or by applying say some method. Then you are getting 4 roots, say 3, 6, 7, 9. All these roots are not equal. They are different. So just substitute m1. What is m1? 3. m2 is 6. m3 is 7. m4 is 9. Just substituting this formula because all roots are equal. Suppose if you are getting only 2 roots, then you are writing only this much. If you are getting only 2 roots, you are writing only this much. C1 e to the power, suppose you are getting only 3 and 6, then you are writing C1 into e to the power 3x plus C2 into e to the power 6x. Now coming to second case. Suppose these 4 roots are equal, m1, m2, m3, m4. All are equal, say. All are equal, m1, m2, m3, m4. All roots are equal. Then all roots are equal means 2, 2, 2, 2, repeating. Then in that case, how to write? For the first root, remember like this, for the first root C1, for the second root C2x, for the third root C3x squared, for the fourth root C4x cubed. In this way you remember, first root C1, second root C2x. Suppose only 2 roots are there which are equal, stop at this point. 3 roots are there, C1 plus C2x plus C3x squared. Up to that only you are writing. If 3 roots are there, you are writing only C1 plus C2x plus C3x square. Now, first one C1, for the second one C2x, for the third root C3x square, for the fourth root C4x cubed e to the power m1x. For example, 2, 2, 2, 2, 4 times this is repeated. Now, just substitute. For the first one C1, second one C2x, third one C3x square, fourth one C4x cubed e to the power. Now, this 2x. Now, let us take the third case. 3 roots are equal. m1 is equal to m2 is equal to m3. 3 roots are equal. But the fourth root m4 is not equal to this. And m5 is also not equal to this. In that case, for these 3, observe, m1 is equal to m2 is equal to m3. When the roots are equal, how do you write? That way you proceed. When the roots are equal, m1 is equal to m2 is equal to m3. For the first root, c1. For the second root, c2x. For the third root, c3x squared into e to the power any one of this m1, m2, m3. These 3 roots are repeated. Therefore, C1, second root C2x, for the third root C3x, e to the power m1x. Next, m4 is not equal to m5. Therefore, C4 into e to the power m4x plus C5 into e to the power m5x. Because roots are different. Now, for example, 3, 3, 3. These 3 roots are repeated. So, for that I will write. For the first root, C1. Observe clearly. For the first root, C1. For the second root, C2x. For the third root, C3x squared. These are repeated. So, repeated 3 times. So, 3 times repeated, therefore C1 plus C2x plus C3x squared e to the power this number 3x. Next, these roots are different 6 and 7. Therefore, C4 into e to the power 6x plus C5 into e to the power this number 7x. Now coming to fourth case. When the roots are complex in nature, alpha plus or minus I beta. When the roots are complex in nature, alpha plus or minus I beta. Then e to the power alpha x into c1 cos beta x plus c2 sin beta x. For example, 3 plus or minus I into 4. So what is alpha? Alpha is 3, beta is 4. Just substitute. Alpha is 3, observe. Beta is 4. Alpha is 3, beta is 4. Just substituting this formula. Now let us go for case number 5. When the complex roots are repeated. That means alpha plus or minus I beta once, again alpha plus or minus I beta. Then this is the formula. e to the power alpha x into c1 plus c2x into cos beta x plus c3 plus c4x into sin beta x. This is the formula. Suppose you got roots 5 plus or minus I into 6 plus 5 plus or minus I into 6, again if it is repeated. Then what is alpha? Alpha is 5. What is beta? Beta is 6. So just substitute. See, observe, alpha is 5. Now beta, what is beta? 6. Here also you observe beta is 6. Now let us take an example. D minus 1 whole cubed into d minus 2 into d minus 3 operated on y is equal to 0. Observe clearly, from d minus 1 whole cube, d minus 1 is equal to 0, therefore d is equal to 1. D minus 1 whole cube, d minus 1 is equal to 0, therefore d is equal to 1. So from this what you are getting? Whole cube. So therefore repeated 3 times. D is equal to 1, 1, 1. Next, d is equal to 2, d is equal to 3. Now these 3 are repeated. So these 3 are repeated means first one c1, for the second one c2x, for the third one c3x squared into e to the power this 1x. Next, c4 into e to the power, these roots are different, c4 into e to the power 2x. This is also different from this, not equal, therefore c5 into e to the power this 3x. Now coming to this one. Next example, d minus 2 whole square into d minus 5 into d minus 6 into d square plus 4 operated on y is equal to 0. Now from this what you are getting? D minus 2 is equal to 0. It means d is equal to 2, d is equal to 2. So therefore 2 roots. Now from this d is equal to 5. Right? From this d is equal to 6. Now for d squared plus 4, you have to find d squared plus 4 is equal to 0. So d squared is equal to minus 4. D is equal to plus or minus square root of 4. D squared is equal to minus 4. D is equal to plus or minus square root of minus 4. So this can be written as 0 plus or minus, or is equal to plus or minus. For minus 1 I, square root of 4 is 2. Observe, for minus 1 I, square root of minus 1 is I, square root of 4 is 2. So d is equal to 0 plus or minus I into 2. So what is alpha? Alpha is 0, beta is 2. Now let us write. So these are the roots. What are the roots I got? D is equal to 2, 2, 5, 6. Here, this 0 plus or minus I into 2. Now these roots are repeated. 2 and 2, they are repeated. Therefore, first one c1, for the second one c2x into e to the power 2x. That is over. This is over. Now coming to 5 and 6, they are different. Therefore, c3 into e to the power 5x plus c4 into e to the power 6x. Next, these are complex. So alpha is 0, beta is 2. Observe, alpha I have written 0, right? Beta is 2. Now let us take another example. 2d squared plus 2 whole squared operated on y is equal to 0. Now, how to find 2d squared plus 2? Now what is this actually? 2d squared plus 2 whole squared means 2d squared plus 2 into 2d squared plus 2 is equal to 0. So from this, if I take any one expression, because both are one and the same, 2d squared is equal to minus 2. So d squared is equal to minus 2. So what is d squared? D squared is minus 2 divided by this 2. So d squared is equal to minus 1. D squared is equal to minus 1. I have written that. So d is equal to, right, plus or minus square root of minus 1. So 0 plus or minus square root of minus 1 is I. So what is alpha? Alpha is 0. Beta is number behind I, 1. So alpha is this 0. Beta is number behind I. So beta is 1. So here observe, roots are repeated. So what is the formula I have to repeat? When the roots are repeated, d is equal to 0 plus or minus I. Again d is equal to 0 plus or minus I, it is repeating. So in that case we have to use this formula, repeated case formula, star. So if I substitute in that star, what is that repeated case? When complex roots are repeated, this is, what is alpha? Alpha is 0, beta is 1. Observe, what is the value of beta? 1. Here, what is the value of beta? Beta is 1. So that is what. Now let us take one more example. T to the power 4 plus 4 plus 4 d squared into d minus 6 whole squared into d minus 5 operated on y is equal to 0. Right? Now, this d to the power 4 plus 4 d squared, I can write that as d squared plus 2 whole square. This I can write that square root of d4, d squared. Square root of 4, 2. So whole square this, you will get this. So this much is d squared plus 2 whole square. So this is d squared plus 2 whole square. D minus 6 whole square, d minus 5. Now from this, observe, from this d minus 6 whole square you are getting 2 roots, d is equal to 6, d is equal. From d minus 5 you are getting d is equal to 5. Now from d square plus 2 whole square you will get 2 complex roots. What is that? D is equal to 0 plus or minus I root 2, d square plus 2 is equal to 0 means d is equal to 0 plus or minus I root 2 you will get. Whole square is there, therefore again you will get it. For example, so therefore, what is the complementary function for this? 6 repeated. This is the complementary function repeated. Now this is not equal to this, so therefore C3 into e to the power 5x. Now this is, observe, repeated roots. I into root 2, I into root 2. So therefore this one e to the power alpha x into 0, repeated case this is. So therefore here what is alpha? Alpha is 0, beta is root 2. Just substitute. Here I have written this as it is. C1 plus C2x e to the power 6x. I have written that as it is. C3 e to the power 5x. I have written that as it is. Here alpha, what is alpha? 0. C1 plus C2x written as it is. Beta, what is beta? Root 2. I have written that as it is. Similarly, C3 plus C4. So this is about this. Okay, let us stop at this point. In the next class we shall continue.